Fischer, a German high-tech brand which you'd mostly know for inventing the type of wall plug we all know and love today. But one of the things they're also making is Fischertechnik, a construction system that started out as mechanical build blocks and has since been expanded to include kinematics, electronics, programmable robot components, and now a 3D printer. Because they typically focus on educational, downsized and simplified versions of industrial machines, it feels a bit weird that they now have released a full-scale, fully functional 3D printer. Or have they? Let's find out. So this is the Fischertechnik 3D printer. It doesn't actually have a specific product name, it's just their 3D printer. On the first look, it resembles something like a Mendel Max, using the classic moving bed with a vertical truss that supports the X and Z axes. The build volume is advertised as 150mm wide, 100mm deep and 80mm tall. However, the included software is only set to a 65mm height. Apart from the 3D printer specific parts, it's built entirely from standard Fischertechnik components, which means there are 890 parts for you to assemble, all revolving around these blocks, pins and profiles that you can interconnect on all 6 sides. And assembling all those parts in one go is not something I enjoy too much, since there are many parts that are very similar to each other and you have to pay really close attention to the exact orientation you're supposed to assemble them with, which isn't always that clear from the manual, and while a wrong part might fit initially, it's going to leave you with a missing or wrong mounting point down the road. And just pushing parts onto the aluminum rails in particular was quite frustrating and painful. Overall, the build took me a good 10 hours, which was, as usual, while entertaining a livestream audience. I did build a few things not exactly to spec, but those bits don't affect the machine's performance at all. I also left out the spool holder, which is a separate part that simply clips onto the back of the printer and can take either the included loose filament sample or full-size spools. The included 3D printer specific parts are carried over from the discontinued German RepRap Neo, and no, German RepRap are not like an official RepRap sub-brand, they're just using the name, and apparently somehow conveniently forgot to mention to Fischertechnik that the printer board clone they're supplying is licensed as open hardware as Creative Commons share alike, and the Repetier firmware which drives the entire thing is covered under the open source software GPL license. This would require Fischertechnik to publish the source code and design files they use for these specific components, but as far as I look, there's not the slightest hint of open source components used at all, let alone the schematics or modified source code shared, which is not only a slap to the face for the open source community and a license breach, but also means that you can't easily modify, for example, the firmware to make your own changes as you modify the printer. You'd have to start from scratch and reconfigure the entire thing. So hardware-wise, we have a traditional PEK-based Boden-hardened with absolutely no cooling fans, neither for the hardened itself, since that's not required, nor for the part you're printing. And we'll get to that in a second. The extruder is a simple direct drive type, which generally just works. Now the print bed is actually just a piece of acrylic with some build tech on top. It's not heated, there's no way of adjusting it, and there's also no sensor-based compensation for that. Mechanically, all axes are driven by these plastic lead screws, which are actually many individual segments assembled onto a 4mm steel rod. These lead screws made with matching Fischertechnik nuts, which simply integrate like one of the regular building blocks and make up for a surprisingly low backlash motion system, and on the Z-axis, both sides are synchronized and connected to the motor with this belt, which you get to assemble yourself from 138 individual elements. The Z and Y axes run on the same type of 4mm rod that's used for the core of these lead screws, while the X axis runs directly on these aluminum profiles with plenty of silicone grease as lubrication. Overall, mechanically, this is one of the floppiest 3D printers out there, just shy of the old wooden Printerbot Simple. Which makes sense, since all of the connecting parts are not just made from plastic, but also contain countless dovetail connections that simply rely on a friction fit. Most of these assemblies consisting of 20 or more individual bits could be just so easily replaced by a single custom-made or even a 3D printed part. But I guess that would be missing the point of this machine. On the electronic side, you'd be hard-pressed to find any luxury features as well. Motors, mechanical end stops, and the heater and thermistor for the hardened That's literally all you get. The Z end stop is adjusted with the same type of lead screw as used for linear motion, plus a jam nut to keep it in place, but this adjustment is so coarse and unreliable that getting the nozzle height perfect for the first layer is complete guesswork. And if you tighten the jam nut too much, remember how those lead screws are individual segments? Yep, you're gonna pull those apart. While the printer board used in here does have the option of adding a heated bed, an LCD screen and SD card slot, and basically everything else you'd expect from a modern printer, those options are not put to use. So just as a 3D printer itself, how well does it perform? Well, better than what I was expecting, but those expectations weren't too hard to beat. Since the 3D printer doesn't have a part cooling fan and is exclusively meant to print PLA, you're always going to end up with parts that show strong curling on any sort of overhang and blobbing if you try to print a fine detail. And because the motion system isn't too precise nor rigid, prints end up quite inconsistent, with mechanical mates rarely fitting on the first try. Getting a good print is often up to luck, and while I was able to get some prints out that were serviceable, the overall print quality is still on the lower end of what is acceptable for a 3D printer these days. There is one print profile and one profile only in the included Fischertechnik branded Repetier host software, but of course you're free to create your own profiles for the Slick 3R or Cura slicers. One of the challenges of getting prints out at all is the print bed. While parts stick well to the included build tag sheet, the bed is absolutely not flat. If I built this printer completely by the manual, it would have ended up with a bed that was even more warped, since you're supposed to clip the acrylic sheet directly to the bed platform, which uses plates that aren't perfectly flat themselves. If you slightly modify this and prop up the build surface by using these gears as a shim between the acrylic and the bed instead of as a washer on top, it already gets much flatter, but still is warped enough to have the nozzle digging into the surface in the center if you also want your parts to stick at the corners of the build volume. Essentially, you need to print larger parts with a raft, which was last popular about 6 years ago. And that's sort of the vibe I'm getting from this machine. In many regards, its features and performance are quite similar to the first attempts at making an affordable printer spawned by the Repro project into something like the Cupcake CNC. So by all means, as a 3D printer, this is neither a modern nor a well-performing machine. If you're looking to buy something that just 3D prints at the price point of 699 euros MSRP for this Fischertechnik machine, there are certainly much better options available. For just a few bucks more, you can get the Made in Europe original Prusa i3 Mark II, which is a fully featured machine that just works. For about 400 bucks, you could get an US-made printer bot Play, which prints much nicer than the Fischertechnik kit, is quicker and, at least for me, much more enjoyable to build and use, and is a much more robust machine. And I don't even have to get into the Far East imports like the sub 200 euro Fabricator Mini, which is probably still a better 3D printer at its core than the Fischertechnik kit. And at this point, I was really questioning things. What if I'm missing something? What if this isn't supposed to be a real 3D printer? I mean, after all, Fischertechnik's mission is education first, so what does it deliver on that front? Well, I personally always keep recommending 3D printer kits over ready-built machines just because of how much you learn about the machine when you assemble it yourself. But I feel like the build of the Fischertechnik machine mostly taught me how to push little plastic pieces together, and the finished machine was sort of a byproduct in the process, considering how much time you spend with creating all the little sub-assemblies versus actually creating larger functional units. In the build manual, you also get a basic explanation of the components used and their functions, as well as a few pointers towards tools and websites to create or download more 3D printable models. This is great as a starting point, as a few other machines just give you the troubleshooting guide, if at all, and tell you, okay, that's it, have fun. But the included explanations aren't super comprehensive either, where they would make for a basis for a school lesson. Also, the info you're getting isn't exclusive to the Fischertechnik machine and is something you could just read up as well on the various 3D printing focused websites and channels. The age recommendation 14 and up certainly makes sense as well, considering how complex the build is and how little the final assembled machine improves on what even budget 3D printers deliver as far as quality, reliability, ease of use, and last but not least, safety is concerned. I mean, the hot end is completely exposed and there's absolutely no way of telling whether it's sitting at 20 or 200 degrees, since there's no fan that spins up or even any sort of LED that would indicate that it's heating right now. Sure, you should be careful not to touch the hot end either way, but I feel like this could have been implemented a bit better. So overall, the Fischertechnik 3D printer feels more like an experiment of how far can we go, instead of an attempt of making an actual functional 3D printer. Things like the mediocre motion system, the lack of an adjustable bed, and not even including a part cooling fan make it barely usable as a 3D printer or even as a 3D printer-like toy to experiment with. Especially at the price, I feel there are just too many options out there that give you a much more robust machine and even a much more enjoyable and educational build experience. I personally really like the build of the Printabot Play, which took me about half as long to complete. That spare time could be used to learn about 3D printers and try out different things with it hands-on instead. Maybe, if you're a huge fan of the Fischertechnik system and want to get in on their 3D printer because it's sort of a cool thing for you, then by all means go for it. But for everyone else, including educators, I can't really recommend the Fischertechnik 3D printer kit. So that's my take on what is certainly an interesting machine. If you enjoyed the review, give it a thumbs up. If you really adored it, subscribe so you don't miss out on any of the reviews, guides and live streams that go up on this channel. If you appreciate what I'm doing here, there are a few ways to support this channel. Join in on the Patreon campaign and be a part of the monthly live Q&A sessions. But either way, thanks for watching and I'll see you in the next one.